Hello, well, everyone, welcome to Driven Math and Physics. So, continuing from where we stopped, we're looking at internal resistance. Now, if you wanted to make internal resistance as a subject of formula in this thing, remember we said that voltage lost equals EMF minus potential difference or terminal voltage, okay, across the circuit. Now, if you remember very well, that voltage lost was equal to current times internal resistance equals E minus current times external resistance. Alright, so that's how it's supposed to be. Now, if we're going to make R subject of formula to be R equals E minus I times external resistance divided by current. Okay, this is the formula that you can use when you're calculating internal resistance. Okay, now I hope these concepts are making sense, but let's just do some calculations just to solidify what we've looked at so far. Now, if you look at this properly, what you will notice is we have two problems, of course. So you'll notice a couple of things. Number one, you'll notice that they've given us EMF that is 3 volts. Okay, so we'll write E equals 3 volts. Okay, and they're saying if the potential difference across the cell is 2.5, this potential difference across the cell is terminal voltage. So we'll say terminal voltage equals 2.5 volts. Then they're saying the current flowing is 2 amperes. Okay, and then they're saying calculate the internal resistance. So from the previous slide, we know that internal resistance equals E minus I times external resistance divided by the current. So if we substitute these things in there, it will be 3 volts minus 2.5 volts divided by 2 amperes. Okay, right there. Okay, so if we do this, it will be 0.5 volts divided by 2. 0.5 volts divided by 2, that gives us 0.25 ohms. That becomes your internal resistance. Okay, that is your internal resistance. This is simply how you do it. Okay, it just needs to come from the understanding of what internal resistance is. You literally don't have to memorize this formula. You just have to remember that if you subtracted potential difference from the EMF, you will get lost voltage. From there, you can break it down and you can always remember this formula. You don't have to memorize it at all. So number 2 is that a battery of EMF 12 volts and the internal resistance 0.6. So they're saying that the EMF is equal to 12 volts and internal resistance is 0.6 ohms. What is the potential difference across the terminals when it's applying a current of, so the current is 5 amperes. They want us to find terminal voltage. Okay, so from there we know one thing that we know is that EMF is equal to potential difference plus V voltage lost. Okay, so I told you don't have to memorize this, so we can substitute there. It will be potential difference is simply the terminal voltage lost is I times internal resistance. So if we know the EMF to be 12, the internal resistance will be 0.6, current will be 5 amperes, we can find the terminal voltage. So if we make terminal voltage subject of formula, it will be PD is equal to E minus I R. So the EMF is equal to 12 volts minus the current in this case is 5 amperes multiplied by 0.6 ohms. Okay, so if we calculated that, so it would end up being 3 there. So if we did 5 multiplied by 0.6 gives us 3, then 12 minus 3 is actually 9 volts. Okay, this is the terminal V. Okay, terminal V. We get it as 9 volts. Okay, that's exactly how you do it. And literally it's just about remembering this relationship right here, that electromotive force is equal to terminal voltage plus voltage lost, or electromotive force minus terminal voltage gives you the voltage that is lost due to internal resistance. This is the concept of internal resistance. We'll stop here for today, but thank you so much for tuning in. Don't forget to hit the like and the subscribe button. Tell people about this channel. I really appreciate the support. Thanks.